Hello everyone, here is Mustafa. In this video I'll speak about the relationship between Kc and Kp. Let's get started. In the previous lesson, I have showed the relationship between delta G, the Gibbs free energy, and K, which is the equilibrium constant, and how the value for K higher than 1 or lower than 1 could indicate the spontaneity of the reaction. We can see that delta G, which is Gibbs free energy, is equal to negative RTlnk, where R is the gas constant, is given in the data booklet 8.31. T is the temperature, which should be given the problem, and we have K, the equilibrium constant. We can observe something here, which is K is not Kc, is not written Kc as we used to write it. So the equilibrium constant in this equation has no subscript. Why is that? Because there is more than one type of equilibrium constant, and which one is obtained depends on the reaction involved. So we have Kc and we have Kp. When should we use Kc? When should we use Kp? We should use Kc when the reaction is involving solutions. When we should use Kp, or when Kp is introduced when we have gases. What is Kp? Kp is referring to the partial pressure. Partial pressure refers to the pressure exerted by a particular gas in a mix of gases. So it's the equilibrium constant calculated through the partial pressure. So we have here's an example for a reaction that has gases. We have nitrogen, hydrogen are reacting to make ammonia. We have Kp, equilibrium constant, calculated through the partial pressure. It is same idea. The partial pressure for ammonia to the power of its coefficient is 2 over the partial pressure for the reactants, so nitrogen and the hydrogen, raised to the power of their coefficients. What's the relationship between partial pressure and the concentration? It could be easily worked out through the formula PV is equal to nRT. So we can directly manipulate this formula, and we will find out that P, which is the pressure, is equal to N over V. What's N over V? It is concentration. So we can refer to the relation between Kp and Kc using this formula. Kp is equal to Kc multiplied by RT over delta N, where delta N is the number of gas molecules on the right-hand side minus the number of gas molecules on the left-hand side. What's the right-hand side? Directly it's products, and the number of moles, number of gas molecules or moles on the left-hand side, which is referring to the reactants. When Kp will equal to Kc, of course, when delta N is 0. So we have here an example for the delta N. Here delta N is -2 because we have here how many molecules or how many moles. We have here 4 moles for reactants, and we have 2 moles for the product. So the product minus reactants will give -2. While in this equation, or in this reaction, we have 2 products and 2 reactants, so delta N is equal to 0. So in this case, Kp is equal to Kc, where delta N is equal to 0.